most of these problems, if not all of these problems, require factoring. I want you to take a look first at number 2448. That's the number you got to find the square root of. In order to factor it, the last number's an 8, that means it's divisible by 2. The last number's a 4, that means it's divisible by 2 again.
Wait, are you just doing this for...
I thought it was a 1.
The last number is a 2, that means it's divisible by 2 again. Divisible by 2 again. Now this time it's not divisible by 2 anymore. So you look at the next largest prime, which is 3. Add the digits together, you get 9. If 9 is divisible by 3, then this number is divisible by 3, and it is. You get 51. Add 5 and 1 together. 6 is right. That's divisible by 3, so this will be divisible by 3. 17 is prime, so we are now done. 2,448 is equal to 2 times 2 times 2 times 2 times 3 times 3 times 17. Okay, 2 to the 4th times 3 squared times 17. If I take the square root of both sides, this will be 2,448 on this side. And since the other side is equal to it, I just have to take the square root of that, 2. Now, 2 to the 4th is the same as 2 squared times 2 squared times 3 squared times 17. The reason I turned them all into squares is if you take the square root of something squared, basically those two operations cancel themselves out. So you have 2 times 2 times 3, and 17 is the only thing left underneath. 2 times 2 times 3 is 12, square root of 17. That's the answer to this problem. Notice that the next problem here has two fractions. One has a denominator with 15 in it. The other has a denominator of 10. If you factor those two numbers, they have a factor in common. And then each one of them has something the other one doesn't have. If I take the something that it doesn't have and give it to it, if I take the 2 and the 3, obviously those numbers are going to turn out to be the same. The top is going to be 30, the bottom is going to be 30. What that tells me is that 30 is my least common denominator. And it also tells me what I have to multiply the top and bottom of the fraction by in order to get that. So 4 over 15 plus 3 over 10, you multiply top and bottom of the first fraction by 2, and top and bottom of the second fraction by 3, you wind up with 8 over 30 plus 9 over 30, and that's 17 over 30, and you're all done. Okay. If you take a look at the next problem, again, it's a fraction times a fraction, but you've got 4 different numbers here. If you can factor them, the answer becomes easy. Now, 11 is prime, so we don't have to do anything to that. The next one, 91, well, let's see. I can divide that by what? Can't divide it by 3, can't divide it by 2, can't divide it by 5.
7.
I can divide that by 7. That would be the smallest prime I can divide that by. So let's do that. 14, easy to factor. It's 2 times 7. And 77, also easy to factor. It's 7 times 11. 11 over 2 times 7 times 7 times 13 over 7 times 11. Now, you may be able to see right away which things divide out, but just in case you can't, if you rewrite these things where the numbers are in order, on the bottom it would be 2 times 7 times 7 times 11. You can line it up. 7 times 11 times 13. That makes it a little bit easier to see how you're going to divide out to make everything go away. You're going to be able to divide a 7 from the top and the bottom and an 11 from the top and the bottom. And suddenly this answer is easy to find. It's 13 over 14. Okay, here's 81 divided by 49. The whole fraction is under the radical sign, so that means both the numerator and the denominator belong under a radical sign. Now, 81 is 9 squared, 49 is 7 squared, so this one's really easy. It's 9 over 7. And the next one's pretty easy too, because this is the square root of 19 squared, which means the square root of 19 times the square root of 19. And if you're thinking of the square root of 19 as the number that you multiply by itself to get 19, well, here we are multiplying it by itself. What do you think the answer is? It's 19. All done. Square root of 63 times square root of 28. Once again, if you factor these numbers, you'll be amazed at how quickly and easily it becomes clear what the answer is. This is 3 times 3 times 7. This is 2 times 2 times 7. Since you're multiplying radicals, everything goes under the same radical sign. So this is 2 times 2 times 3 times 3 times 7 times 7. Hey, each one of those can be brought out from under the radical sign, so it's 2 times 3 times 7, and it's 42. The end. The next one is equally easy, although the answer isn't a whole number. Square root of 35 times square root of 14. That's the same as the square root of 5 times 7 times the square root of 2 by 7. Well, when I put them together, 2 times 5 is what's left underneath. 7 times 7 is under there, which means I can bring that out and make that 7 times the square root of 10. And that's the answer. Yeah. Well, then show it to me and I'll fix it. Square root of 4 over 7 means the square root of 4 over the square root of 7. And in certain situations, we try not to leave a radical sign in the denominator. If you're asked to simplify it, then that means you need to rationalize the denominator. It means multiply top and bottom by the square root of 7. You get 28, square root of 28 over 7. Of course, I went too fast here. All I had to do was look and say, wait a minute, the square root of 4, that's 2. It's 2 square root of 7 over 7. That's the answer. Square root of 54 plus square root of 96. At first, they don't really look like they go together. And yet, if you factor these numbers out, let's see, 96, 2 will go into that. Hey, 2 will go into that one too. 2 will go into that one. 2 will go into that. I'm going wild here with 2s. Oh, and a 3. So what do I have here? I have square root of 54 is the square root of
3 root 6.
2 times 3 times 3 times 3. And this is the square root of 2 times 2 times 2 times 2 times 2 times 3. So yes, when you take out the perfect squares, you've got 3 square root of 6 plus, there's 2 more, that's 4 square root of 6. 4 square root of 6. And that becomes 7 square root of 6. And that's the answer. Exactly. The last one, well, it's just the same exact thing we've been doing, only in a generalized form. If you have 3 times a squared times b cubed, you take out an a, you take out a b, what you got left underneath is 3b. So it's a times b times square root of 3b.